Okay, so an alternative to using the Gentian Violet for the adhesive side of tape is to use Tape Glo, which is a commercially manufactured product that is designed to work effectively on the adhesive side, and it also has a fluorescence capability to it as well. It is also reacting with the lipids in the print, and so I'm going to put some prints on this piece of duct tape here. Put a few prints on the adhesive side, and I'll just cut this off here. Set this aside for 1 second. And we can maybe look at another form of tape here as well. So maybe we'll do it with some black electrical tape to see if the fluorescence will work on this as well. Obviously, if we've got prints that are on the adhesive side of electrical tape, it's going to be much darker and more difficult to see prints that might develop a pinkish color or an orange color with just the Tape Glo solution, and more necessity to have it with the fluorescence that we can apply after the fact. So I'll put some prints down here now. Okay, so we now have prints on electrical tape and on duct tape. So just glove back up here. Now the Tape Glo, much like the Rodeman 6G, probably a little bit stronger a color, is also an kind of an orange color with a little bit of a pink tint to it as well. It does have a shelf life. This is a water-based product. You simply pour it into the dish. This can be reused as well, as long as it hasn't been contaminated. You can reclaim the surplus and reuse it again. And so, same type of process as with the Gentian Violet, by saturating the tape in the tray. With this here, I just agitate. I hold the tape down with the tweezers, and then just kind of agitate the tape, or agitate the tray with the tape in it, to try and rinse over the surface. Again, it's working with the lipids. Hopefully it's going to develop prints that are an orangey pink color, and then used in conjunction with a 450 nanometer wavelength of light and a orange barrier filter, orange goggles, we should see some prints show up. So prints are starting to develop there. I'll just give it a few more seconds here in the tray. May see some prints show up naturally under available lighting conditions, but the fluorescence will be generated as well. So I'll take this out. This can also be rinsed using distilled water, so I'll just give it a bit of a rinse here. Now, you can see the prints developed here. You can see that faint orange color, and we'll after we process the black electrical tape the same way, we will look at the alternate light source and orange barrier filter and see what kind of fluorescence we get. So we'll set that aside for a moment, and we'll do the same with the black electrical tape. And the tape wants to tend to float, so by holding it down with the tweezers and then just agitating the tray so that the solution kind of cascades over the top of it, repeat the same again by using the distilled water to rinse that. And we'll set this down as well. Okay. So we'll set that aside for now. And again, obviously, because it's a dark color with the tape, with the electrical tape, you can't really see the prints that are visible or potentially visible there. And so we'll come back momentarily with our alternate light source and viewing goggles. Okay, so we've got it set up now. You'll notice again, you've got that orange view when you're looking through. We've affixed the barrier filter to the lens of the camera. And Agata's now going to turn the lights off, and we'll have a visualization with the ALS. And again, we're using that low output 455 nanometer wavelength, and so hopefully we'll get some fluorescence. Let me hold this up so we can see.
Oh no, I see it.
See okay?
Mm-hmm.
So lots of fluorescence there on the duct tape, and also you can now see the fluorescence on the black electrical tape that was not visible under normal lighting conditions, primarily because of the color of the tape itself.